Alright, unit summary. Let's do this. So, defining y-intercepts. A y-intercept is what you get when you do nothing. Y-intercept, also known as the output. Your output is usually found on a table on the right side, and on a graph, your output is usually found on the y-axis. Now, x-intercepts. An x-intercept is what you do to get nothing, also known as your input. Normally on a table, your input would be found on the left side of the table, and on a graph, the x-axis. Now, vertex. A vertex is the point where the direction of your parabola will change, also known as your highest or your lowest point on the parabola. Basically, when you're looking at a parabola, it is a U-shape. And wherever the parabola changes direction, so if it's going down, then it starts to go up, you find your vertex. Now, describing a quadratic on a graph. This shape of this function is a parabola that points up. Here we have the example for a graph. Now, as you can see, it is a U-shape, so it is a parabola. As you can see here, I have my vertex, which is the lowest point of my parabola. Then here, I have my x-intercepts, and up there is my y. Now, to find the line of symmetry in a graph, you're going to want to look for the spot where the vertex hits the x-axis. Basically, you're going to look at your vertex. If it's on the bottom, you're going to start going up, and once your vertex hits the x-axis, you find your line of symmetry. The line of symmetry for this example is x equals -3, because if you look at the vertex on my example, on the x-axis, the point where it hits is -3. Now, to find a y-intercept from a graph, you're going to want to find where the line crosses the y-axis. Basically, for your parabola, it's going to cross the x and the y-axis. Wherever it crosses the y-axis, you find your your y-intercept. As you can see, I have circled my y-intercept because that is where my parabola crosses the y-axis. Now, in this example, my y-axis, or the point where my parabola hits the y-axis, would be 8. Now, for an x-axis, as you can see, I have two x-axes. Both of them are circled, and both of them are on the x-axis. How you know these are your x-intercepts? Well, your x-intercept is where your parabola hits the x-axis. And when you find your x-axes, or your x-intercepts, you are going to be able to find your factored form. Your factored form is basically what helps you to find your x-intercepts. But you can also use your x-intercepts to figure out what the factored form is. For factored form, you're basically going to take your two equations, set both equations equal to 0, and whichever number you must plug in to get 0, it's going to be your x-intercepts. So as you can see here, my x-intercepts are -4, and -2. Alright, describing a quadratic from a table. The shape of this function is a parabola that opens up. Now here we have my table. As you can see, I have my y-intercept, my x-intercept, and my vertex labeled. Now, normally you're going to want to circle each of these. For this example, I didn't. Now, to find the line of symmetry in a table, you're going to want to find the vertex. And the line of symmetry is the x value of the vertex, also known as the input. The vertex in a table is found between the x-intercepts, and your vertex will most likely be the highest or lowest point on your table. Now to find a y-intercept. I'm kidding. We're still on the line of symmetry. So basically, for finding the line of symmetry on a table, you're going to want to look for where your x-intercepts are located. And the point that is right in between is going to be your line of symmetry, because the point that is in between your x-intercepts is your vertex. And as you can see, the input from my vertex is -6, meaning that the line of symmetry for my example is -6. Now, to find an x-intercept from a table, you're going to want to find where the y value, also known as the output, is 0. Now, as you can see, I have my y-intercept up here. I have it labeled 0 and 27. Now, as you can see, my input is 0. And my output is 27, meaning that this is a y-intercept. Now to find an x-intercept from a table, you're going to want to find where the output, the y value, is 0. Now, on my table, I have 2 x-intercepts because on my table, there are 2 inputs that have an output of 0. As you can see, I have -3, and -9. Those 2 are my x-intercepts because the output is 0. Okay, now the factored form, once more. You're basically doing the same thing as you did on a graph for your factored form. You're going to find your x-intercepts, and you're going to use these equations, set them to equal to 0, and whichever number you must plug in to get 0 is going to be your x-intercept. Pretty simple. Now, describing a quadratic from a standard form equation. The shape of this function is a parabola, and it also opens up. Funny how all of my examples open up. Here you see I have my equation, and it is in standard form. And below my equation is the box that you can use for factored form. Now, to find the line of symmetry in an equation, you can use the factored form and find the x-intercepts. You're going to want to add the 2 inputs for your x-intercepts together, then you're going to divide the result by 2. And whichever number you get is your line of symmetry. Okay. As you can see, my x-intercepts are -9 and -5. Once you add the inputs together, you're going to come down to -14. And then, once you get that result, you're going to want to divide it by 2, which will give you -7. And as you could see, the line of symmetry for this example was x equals -7. It's pretty simple, you know? Now, to find an y-intercept from an equation, find out the standard form, and the number that isn't a coefficient is the y-intercept. When you have a standard form equation, you're going to want to substitute the variables, also known as the x's, for 0 to help you find the y-intercept. Whichever number is left over will be your y-intercept. Now, as you can see, I have multiple x's in my example, and you're going to want to plug in 0 for each x. So basically, you're going to turn that x squared and that 14x into zeros, leaving only the 45 left over. That 45 is going to be the output for my y-intercept. Now, to find an x-intercept from an equation, you're going to want to find the factored form and set each equation to 0. Whatever number must be plugged in are going to be your x-intercepts. As you can see, here's my factored form, x plus 5, x plus 9. Now, you're going to want to set those equations equal to 0. Basically the same thing you're doing as a graph or a table. Now, as you can see, I set those equal to 0, and the numbers I got were -5 and -9. So, the x-intercepts are -5 and -9.